In this lesson, we're going to look at dividing complex numbers. But in order to divide, we're looking at something like 4i divided by, let's say, 5 plus 2i. Well, when we're dividing, we don't want to have imaginary numbers in our denominator. Just like when we divide by radicals, we don't want to have a radical in the denominator. And we have to rationalize our denominator. We're going to be doing the same thing with complex numbers. So we don't want to have I in the denominator of our fraction here. So we need to get rid of I in the denominator. So how are we going to do this? Well, if we look here, I have 5 plus 2i times 5 minus 2i. So in order to do division, we're going to have to be good at doing multiplication. So what do I notice? Well, I notice I have 5 plus 2i and I have 5 minus 2i. So I have opposites here. Well, if I go ahead and multiply these, if I take 5 times 5, I get 25. 5 times negative 2i, I have negative 10i. And then if I take 2i times 5, I have positive 10i. And I take 2i times negative 2i, I have negative 4i squared. Well, what do I see is happening here? Well, I have 25. My i's cancel. Negative 10i plus 10i is 0. Those cancel. And then I squared, remember, turns into negative 1. So I have no imaginary numbers anymore. I have all real numbers. So I have 25 plus 4, which gives me 29. So what I notice here is if I have positive and negative, if I have opposites, I can get rid of my imaginary terms. So if I want to get rid of the imaginary term in the denominator, I have to multiply by its opposite, because then I will get all real numbers in the denominator. But if I just multiply the denominator, that's going to change my entire fraction. It changes the problem. So what can I multiply in order to get rid of my denominator, I in my denominator, but also keep the problem the same? Well, multiplying by 1 keeps the problem the same. Well, anything divided by itself is 1. So I have to multiply the top, the numerator, and the bottom, our denominator, by the same thing in order to keep the problem the same. And I'm going to also have to get rid of my denominator. So in this case, I would end up having to multiply by 5 minus 2i and 5 minus 2i in the numerator and the denominator to keep the problem the same and to get rid of my i's in the denominator. So we're going to go through and we're going to work with simplifying with division. So instead of just saying we're multiplying by the opposite, we're going to use a little bit of more technical terms. So it's called a conjugate. So conjugate of complex numbers. So our complex conjugate is what we're looking at and referring to as our opposite. So the conjugate of a plus bi is a minus ei. So what is the conjugate of 2 plus 4i? Well, it would be 2 minus 4i. We change the sign of our imaginary term. So then if we started with a minus bi, our complex conjugate is going to be a plus bi. So if we had 7 minus 3i, our complex conjugate would be 7 plus 3i. So we're always going to multiply by the complex conjugate in order to get rid of our imaginary term in our denominator. So now formally getting into dividing complex numbers. So to simplify a quotient with an imaginary number in the denominator, we must multiply by a fraction equal to using the conjugate of the denominator. The process is called rationalizing the denominator. So we're getting rid of that imaginary unit. So here's an example. So if we have 3i divided by 4 plus 2i, we need to get rid of I in our denominator. So we need to multiply, we need to multiply by the conjugate. So if we have 4 plus 2i, our conjugate's going to be 4 minus 2i. Well, if I just multiply the denominator, I'm changing my problem. So I don't want to change the problem, I want to keep it the same, so I have to multiply by 4 minus 2i in the numerator as well. Because 4 minus 2i divided by 4 minus 2i is 1, and that's not going to change my problem. Keeps it the same. So now I just have to multiply through. So on the top, if I multiply, I have 3i times 4 and 3i times negative 2i, which gives me 12i minus 6i squared. In my denominator, I have 4 times 4, 16, 4 times negative 2i, negative 8i, 2i times 4, positive 8i, and 2i times negative 2i, which is going to give me negative 4i squared. Now I can see that my two middle terms cancel my i's, which is what our goal is. And from here, I just need to go ahead and simplify. So if I'm simplifying, I have 12i minus 6 times negative 1, because remember, I squared equals negative 1. And then in my denominator, I have 16 minus 4 times negative 1. So in my numerator, I have 12i plus 6, and in my denominator, I have 16 plus 4. Now remember, when I'm writing complex numbers, I always want to have my real number first. So I would have 6 plus 12i divided by 20. Now, awesome, super fantastic if you can get to this point. However, I can go ahead and simplify this a little bit further. So if I have 6 plus 12i divided by 20, I have 3 different terms here. So I have 6, 12i, and 20. Well, each of these pieces can have a 2 taken out. So I could divide out a 2 from my answer here. So if I take a 2 out of 6, I have 3. If I divide out a 2, I have 6i. And if I divide out a 2, I have 10. Now 3, 6, and 10 have nothing more in common, so this would be my final answer. You can only simplify further and divide out if all 3 of these pieces are able to take a piece out. Otherwise, I'm changing the problem again. So 3 plus 6i divided by 10.